Okay, hello everyone. Good afternoon. Thank you for joining me for this session. So today we are going to take a deep dive into DynamoDB database. Uh, I have done, you could say, a prerequisite session for this particular session when there was in person before all this COVID started. So if you are someone who had attended that, then this will be a good extension to what we discussed in the last, you could say, topic. If not, don't worry. I have something for everybody here. Okay, so what is the agenda? So agenda for today is we will first quickly see what is NoSQL. We are not going to invest a lot of time on that. Then we will start with the DynamoDB architecture. We will see how we can manipulate data in DynamoDB, and then we will look at some of the basics of data modeling in DynamoDB. A little bit about me. So my name is Anurag. I am a co-organizer of AWS User Group Pune, and I work as a cloud and database lead. So I am currently employed at a startup called as IQ Innovation Hub. We are based out of Pune, and you can find me on Twitter and LinkedIn on this handle. And I occasionally also blog on my website www.anuragkare.in. So if you fancy, you could say reading some stuff on AWS or databases, you should definitely consider joining me on any of the social media platforms. Okay, so let's get started. So what exactly is NoSQL? So if you look at the definition that is given at Wikipedia, so basically it says it's a mechanism of storing the data which is other than relational databases. So it's a very vague definition, and it has led to, you could say, basically anything that did not use relational types of, you could say, the relational types of storing the data to be called as a NoSQL. NoSQL, as an acronym on itself, stands for not only SQL. So what basically it's a kind of a marketing jargon which says that it not only has SQL capacities, but it has something more as well. Okay, so there are majorly, you could say, four types of NoSQL databases that people might argue there are more, but then again, like I said, so the broad definition of it makes it difficult to categorize it very clearly. So the four major types that we see in market currently are key value stores. There are then graph databases, there are document databases, and then there are column store databases. So trying to give you an example. So key value store, so the DynamoDB that we are going to see, it's an hybrid of key value and document store. For graph databases, there is something called as NeptuneDB in AWS world, or you can also see Neo4j is another graph database that you can see in the open source world. So in terms of column store, there is very well known, you could say, column store called as Apache Cassandra. Right now, so like I said, so NoSQL or DynamoDB kind of started as a key value store, but if you look at the documentation right now on AWS website, you will see that they say that it's a key value and a document store. So the reason for it we will discuss as we go along. So let's dive deep into what exactly DynamoDB is and its architecture. Okay, so DynamoDB is, like I said, it's a mixture of key value and document store NoSQL databases. It is a no-ops database. So what basically no-ops means is you don't need to worry about provisioning. You don't need to worry about I need these many kind of server, this much of RAM. How do I add machines in the cluster? Everything is managed by, you could say, AWS. That is why it is called as no-ops database. It is built for scale. So what basically it means is you will get the same type of single millisecond response for your operations. If your database, let's say, size is 1 GB or 1 TB or 10 TB. So that is the commitment from AWS for you. The access pattern of DynamoDB is a little different. DynamoDB is accessed via HTTPS, and the authentication happens via IAM. If you look at the relational databases, it generally happens through persistent TCP connections, but here it's all HTTPS API-based access in general. It also falls into the category of hyper-ephemeral compute, which basically means that you are paying for what you use and rather not paying for what you are not using, or it can scale up and down as required, which is very difficult to achieve in terms of the traditional architectures. The other examples of hyper-ephemeral compute in general are Lambdas, AppSync, and that kind of services in AWS. Let's talk about the architecture. So basically, you could say DynamoDB is actually a distributed database. So when we say distributed database, it means that it is running on something called as clusters. So clusters are nothing but, you could say, a group of computers that are joined via compute, so that you can create a huge amount of compute, and you could say huge amount of compute, huge amount of RAM that is generally not achievable if you are just looking to scale your single computer vertically. That means adding as much RAM and as much compute inside one machine. Um, Now, when we talk about distributed systems are, you could say, governed by something called as a cap theorem. So what cap theorem says is there are three vertices to the cap theorem. As you can see, there is consistency, availability, and partition tolerance. So what cap theorem says is at any moment of time, at any moment in time, so you can only achieve only two of these three features in your distributed database or your distributed system. So what that basically means is you have to compromise on one of the vertices of this particular triangle. So in terms of DynamoDB, you could say it compromises on a little bit on consistency, and hence the database is called as an eventually consistent database. So what it means, we will dive into it in the next couple of slides. So on the left side, you see how very vaguely the architecture is. So there is something called as a router, which has the values or which has the addresses of different nodes that are present in our distributed system. And whenever there is a client request, so the header, which generally is the primary key, is hashed, and depending on the value of that particular hash, the router will send your request to the appropriate node depending on that hash value. Now, this hashing is in consistent time, which means in terms of complexity, it is an O of one operation. So we will dive deep into it in the next session. So, and also the other important point is whenever you write a data in DynamoDB, it is by default replicated across at least three partitions. So there is always high availability for you by default in NoSQL in DynamoDB. So we talked about eventual consistency. What exactly does eventual consistency mean? Like I mentioned in the last slide, that whenever you write data, the data is captured in at least three different nodes. Now let's say on the left part of this particular diagram, so let's say there is a write. So of the three systems that were chosen, there is always a leader, and there will be two you could say followers or peers or successors. So when a write is considered as, you could say, success, when it gets confirmation from at least two nodes. So in this case, from node 1 and node 2, it got success. So this write is considered as successful. Now, it might take some time for that particular write to replicate or to propagate in the third, you could say, storage. So what it has an implication. So in terms of read, now moving on the right side, you will see that there is a 33% chance that if you are trying to read the data which has been just written, that you are going to get stale data, which means the data before the inset or update, whatever. So there is a 33% chance that you'll get stale data. So this is the eventually consistent model. So if you look at the cap theorem, AWS has put their money on consistency and partition tolerance, which are the base necessities. Or you could say partition tolerance is a base necessity, but you have to choose between consistency and availability. So they have chosen to be more consistent and keep availability as eventually consistent. Eventually consistent also means that after some time there will be 100%. There is a 100% chance that the data is available in all storage nodes. But
if you are making a read in terms of before the data is read into the third node, then you have a good chance of having a stale read. Now, this stale read can be, you could say, you can make sure that you're getting consistent, or you could say the updated data by providing a parameter when you read a data in your API calls or CLI calls. It is called as a consistent read parameters, but it also has some implications that we will see in the next few slides. So let's look at the architecture. As you know, there is this concept of availability zone. A region in cloud computing is a physical data center. But within the physical data center, what they have done is they have three different buildings, which are totally three different places, which are isolated from each other, which make up that particular region. So, for example, in AWS Mumbai, there are three regions: AP South 1, 2, and 3. Each of these AP South 1, 2, and 3 is called as an availability zone. So when you create a DynamoDB, what it basically does is it has a bunch of routers that is spanned across different availability zones. Similarly, it has spanned all the storage and compute nodes across this availability region. Let's say you make a call via network to your DynamoDB, then it will go to one of the routers, and using the hash value, the router will choose any three random storage nodes within three different availability zones to replicate your data. So as you might have figured now, DynamoDB is actually a closed source proprietary database. So how AWS does that under the hood is not totally revealed, but if you are someone who is intrigued by the distributed systems, you should definitely take a look at the source that I have mentioned at the bottom of the slide. Okay, so this was about DynamoDB, its architecture. So let's look at some of the terms and the nomenclatures that are there in terms of the DynamoDB, and a few of these concepts could be applicable to other NoSQL databases as well. So here are a few terms that we will look into. So the first one is WCU and RCU, which stands for write capacity units and read capacity units. So WCU and RCU will determine how much bill or how much capacity you are going to provision in DynamoDB. Then we will look at the concepts like what is a table, what is a primary key, item, attributes, and then secondary indices. Let's look at the very important point, which is RCU and WCU. So DynamoDB actually operates in two modes. One is called as provision mode, and the other is called as I can't recall. So it's a provision mode and then defined mode. So when I say provision node, you basically are providing to DynamoDB that these are the number of reads and these are the number of writes that I'm expecting from DynamoDB. And depending on that particular read capacity unit and write capacity unit, your bill is given. Now, the other mode is a little flexible, which has been recently introduced and it is useful if you are not yet sure about your application's read and write capacities. So that is something, a flexibility that you get with you could say DynamoDB. But of course, it means that if you are using the flexible mode, you are incurring a little bit more charge as compared with the provision mode where you are defining RCUs and WCUs. So let's see what an RCU is. So RCU is a unit which helps you determine how many reads you are requiring out of DynamoDB. So you are saying that if you are having one strongly consistent read per second or two eventually consistent read per second out of DynamoDB of size total 4 KB, that is a 1 RCU. Similarly, when you are trying to write a data, so let's say you are making one write per second for an item up to 1 KB in size, that is called as one write capacity unit. So you will understand what an item is in the next examples. Now let's say that your system requirement is your each item when you are trying to read is 3 KB in size, and your application requires 80 constant or consistent reads per second.
So and you require 10 writes per second for an each item being 1.5 KB. So the, you could say, calculation is the read capacity unit will be 80, which is your how many consistent reads that you need. Then all the reads, like I mentioned in the definition, are in the 4 KB size. So whether you are reading 1 KB, 2 KB, or 3 KB, you could say item, it is always rounded off to 4 KB. That is why in this formula, I have rounded up it to 4 KB divided by 4 KB, which is the maximum size, and it gives you 80. So when you want to provision your DynamoDB, you should say that I need a RCU of 80. Now, similarly for write, it is like 1 KB in size. So you are dividing your 1.5 KB requirement with 1 KB and into 10. So you are getting 20 write capacity units. So when you want to provision, when you are into the console AWS console trying to provision the database, and you have chosen provision node, you should enter RCU as 80 and WCU as 20. Now in, you could say, the other mode or the flexible mode that I talked about, you don't need to specify this. You will be billed a little more as compared to the provision mode. But let's say in a month or two, when you are confident about your you could say usage pattern, you can come back again and then define these RCUs and WCUs to reduce your bills. One point to note is you can jump between this flexible mode and this provision mode only once in 24 hours. So if you're making the switch, you need to be a little careful, because you cannot change it for next 24 hours again. So let's look at the concept. So this is a table inside DynamoDB. So a table resembles a general relational table. So it's a combination of primary keys, attributes, and its attribute values. So collection of items is called as a table. So there is something called as primary key. In primary key, we have two types. There is a simple primary key, wherein this item name as that you saw here acts as a partition key. And there is also something called as a composite primary key, wherein you will have a combination. Your primary key will be distributed in partition key and sort key. Now let's talk a moment about what a partition key and a sort key means. For this, I'll go back to the architecture diagram for a moment. So here you see in network call, when you made a network call to your router, so you are basically providing your primary key. Now this primary key could be the simple or the composite primary key, and depending on the hash value of this particular primary key, you are allocated a particular storage node. Now each of these primary keys will act as a partition key. So when I say partition key, what basically it does is, let's say you are writing something as order 001 that you see in this table on the left. So order 001 is consistent across all these 4 different entries that you're seeing at this moment. So all these you could say rows of data that you're seeing, or tuples as it is referred in relational databases, they are kept inside a single storage node for faster reads. Now this the value of your partition key actually defines where the which storage node your entire row or an item, as it is called in this particular domain, is going to reside. So in terms of the so we talked about primary key and composite primary key, and the sort key is used to filter the data inside that particular partition. So again, in this case, you see that the primary key is order ID 001 everywhere on the left, and on the right there are 4 different sort keys. So item 156, 57, 58, and profile. So if you wanted to do something like fetch me the details of order 1001 and I want to know the profile associated with that particular order, you will say get pk, where order where the so pk is order ID has 001 and sort key is profile 0010. Yeah, so these so what exactly is an item? So your combination of primary key, its attributes, and its attribute values, that particular single tuple that you are seeing is called as an attribute, the one which has been highlighted. So order 001 and item 156, this is a single item. And as a collection, now when you see that the left primary key or the partition key is 001, this entire collection of item 156, 157, 158 and odd profile 010 will be called as an item collection. Now if you carefully observe towards the right, you will see that the attributes are different in each of these items. So this is a flexibility that you get when you are using NoSQL databases. So you don't need to define your schema upfront. You can have as many attributes as you want against one particular item, and you can have different values inside that attribute as well. So for example, item 156 and item 157 under order 001, you will see on top it has 4 attributes and 4 attribute values, but on the second line you see that it has only 3 attributes. One of the attributes that the category is missing. But if you see the third entry, you will see that the order of this entire thing is different. And if you see at the fourth attributes, the fourth item, sorry, you will see that all the attributes are totally different. So this is the flexibility. Now let's say if you wanted to add a new attribute on item 156 as dealer price, and you want to put it as 15. So if you were in relational word, you'll have to first add a column as dealer price, and it will affect all the items which is present. And if you're not storing the value of that particular, let's say, dealer price for item 157, you're basically wasting storage because it is already provisioned when you create a column. So this is something that does not happen in DynamoDB. So here you get flexible attributes and flexible attributes value. You can add, remove, update, delete as many attributes to each item as you want. So one hard limit that we have at this moment is each item size cannot exceed 400 KB. So that is something which is something that you need to take into account. Now we already talked about attribute and attribute values. So for this particular item, order 001 and item 156, these are the 4 attributes and its corresponding values. So this is how overall a table would look inside your NoSQL database. So I mentioned about let's go back to the menu that we saw. So we talked about WCU, we talked about tables, primary keys, items, attributes. Now let's talk about the secondary indexes. So as you might have guessed, when I created a composite primary key, it is nothing but it resembles to a primary key inside your relational databases, but it is also a default kind of index which helps you get the values quickly. So the hashing is as you have seen in the architecture diagram, you use something called as hashing, and hashing is only possible and quicker only if we have an index in the background. So primary key has an index and it is the primary index, but you have something called as secondary indexes as well. Now secondary indexes actually have 2 types. There is a local secondary index and a global secondary index. So what basically is local secondary index is, in local secondary index you can define a second sort key for the same primary key in your table. So going back to this particular example, here you see that the partition key is order ID and the sort key is item hash. But let's say tomorrow you want to have an access pattern, or you want to look at the filter by category. So what you can do is tomorrow you can replace this sort key with the category attribute, and your partition key is going to remain the same, but you will have a different sort key. So this is called as a local secondary index. Now there are some limitations for local secondary indexes. It uses the capacity of the base table. So when I say capacity, let's say when you define that you need 80 RCUs and 20 WCUs, any query made to the local secondary index is consuming out of that particular capacity. Also, there is a very hard limit that your local secondary index cannot span more than 10 GB per partitions. The other limitation is you need to create the local secondary index only at the time of creations. You cannot go after 6 months of having your tables and then say that I want a local secondary index. That is something which is not possible at this time. One good thing about local secondary index, not everything would be bad. So you can request consistent reads from LSI. So remember I mentioned that there is this parameter called as read consistent reads. So with that consistent reads, you can request for you could say consistent reads from LSI. This is something that is not possible in the global secondary index.
Now, talking about global secondary index, in global secondary index, what you can do is you can have a totally different primary key and a sort key for your table. So in the background, what it does, it replicates your table, the entire table, but it will have a total different primary key and a sort key. This is a very useful scenario, and it helps us determine a lot of it helps us implement a lot of you could say access patterns when it comes in the real life world. The other point is you need to provision different capacity for a global secondary index. Now, when you say that you wanted 80 reads and 20 writes on the table, you have to provision, you need to do the calculations similarly for the global secondary index, and you have to come up with the calculations for the global secondary index differently. So as you might have guessed, the charges, the more the WCUs, the more the charges. And since you are having secondary global secondary index, the charge for the base table will be different, and the charge for the global secondary index, or you can, it is nothing but a replica of your table with some different primary key and sort key, will be different. There is this hard limit again that all the reads and writes will be eventually consistent. So here you cannot provide that particular attribute, and you cannot request consistent reads. The other upside is it can be created and deleted anytime. So there is no limitation that as we saw in local secondary indexes. And the other limitation, as we said, that only eventual consistent reads. So let's take a moment and try to compare how it is different from relational databases. So basically, you don't have the good old SQL is not applicable. You cannot use the good old SQL to write queries on top of DynamoDB. It is rather done by using APIs and CLIs. We are going to look at them in the next section. Also, NoSQL database also implies that you do not have joins. So basically, when you are implementing a NoSQL database or a DynamoDB database, you must denormalize it as much as possible. The reason being that in 1970s, when you could say relational databases were invented, the biggest problem, there were two biggest problems. One was data consistency and the other was storage cost. But nowadays storage has become very cheap, but compute has become very you could say costlier. So it's okay to denormalize because storage is cheaper anyways, and try to save on as much compute as possible. So that is the entire philosophy behind you could say relational the NoSQL databases or DynamoDB. So if you want to join mimic the joins, so you have to denormalize the database and define your access patterns accordingly. So it is also inherently not totally acid compliance, atomicity, consistency, integrity, all that stuff. But there is a small workaround available wherein you can have transactions defined inside that, but inside a particular API call, wherein you can bunch a different, or you can bunch a different read or writes into a single transaction. So you can so only that is the only thing that is available. But the consistency, integrity, it is something that is now given to is now a responsibility of application to take care of. uh, Also, with DynamoDB and NoSQL, there is this new design pattern that has arisen, which is called as a single table design. So basically, what you do is, if you whatever entities that you have in a relational database, or whatever entities that you have identified for your application, they are basically fit into a single table, so that you can define, and the access patterns are defined by using primary keys and secondary indexes. How it is done, we are going to look at it, as I have a small example for us in this particular slide as well. Also, you could say there is this limited filtering, because we are from relational databases. We have this good old where clause, which can be used practically on any column to do any types of filtering. But when it comes to DynamoDB, you will find that you have to do the major chunk, or you could say 95% of your filterings, by just using primary key and sort key. That's it. You cannot there is very limited filtering opportunities when it comes by when you want to do you could say filtering by other attributes.
Also, there are a few major missings when it compares to relational databases. So like we mentioned, there is no join. Also, we are missing something called as constraints. So other than primary key, you do not have any of the constraints. You do not have aggregation and grouping by default. There are some advanced design patterns by which you can do aggregation and grouping, but again, it is something that we are used to having by you could say by default in the relational databases. Also, locking on this, but on any rows that you do, this was something that was taken care by relational databases, but you will have to use something called as you have to do this locking in the application layer itself. So that is another you could say heavy lifting that has been transferred to the application layer. Also, the data integrity, as the database is not totally ACID compliant, so maintaining the integrity of the data becomes the responsibility of the application. Okay, so that's about what DynamoDB is and insights of it. So then now I made a big statement that we do not have SQL interface on top of DynamoDB. So if that is the case, how exactly are we going to manipulate the data in DynamoDB? So there are three there as I in the introduction I mentioned that all the accesses via HTTPS. So it's a no-brainer that all the accesses will be via APIs. So there are three major buckets of APIs. So the first bucket is item-based APIs. So item-based, as the name suggests, you can do actions on a single item in this particular API actions. Then there is something called as a query, and there is something called as a scan. Let's look at them one by one. So item-based API actions. So basically, there are, there are in terms of the accesses, there are two types of you could say accesses that you can do. So you can import an SDK inside your application code size. It could be Python, Java, and then interact by using these API actions. Now, these API actions that you see on the screen are for application level, but you might say, okay, I am an sysadmin, or I am just a database developer who wants to take a quick look. So for that particular use case, we have something called as CLI. So let's look at the item-based API actions. So I have just taken a very few item-based API actions and shown you on the screen. There are a lot more that can be found at the link which I have mentioned below. So these are four major API actions: get API, put API, get item, put item, update item, and delete item. And their equivalent of SQL is select, insert, update, and delete respectively. So when you say get item, it is going to perform an activity such as select in the database and get it back to you. Put item is basically to write or make an insert inside the DynamoDB table. So there is one caveat here that if you are providing the same primary key or a duplicate primary key which is present inside the database, it is going to overwrite your application. So like I again mentioned, the data integrity is something that needs to be taken care from the application layer. Now, this is a very peculiar case of update item. So update item is a very good, or you could say a little complex API action. So it will create an item if it is not present. When you say update with some primary key, and if the primary key value is not present, it is going to create a new item for you. Or it can add, remove, and alter attributes and the values which are present for the existing primary keys. Delete item is basically used to remove the items or delete you could say the entry of that particular entire item. There are more API actions like actions that you can take a look at in the documentation. Now, like I mentioned that let's say you are just a developer or you want to write an ad hoc query. So how exactly you're going to access? So there is something called as CLI actions that you can use. So CLI is command line interface. So you can go inside your terminal, or you can use something as Cloud9, and then fire these commands to get that particular data. So the SQL equivalent of select is AWS DynamoDB get item, the name of your table, and then you see that I have provided something called as a key file, and it has some JSON value in it. So what is that JSON? We will see in a moment. So I'm going to go to the next screen. Now you see on the select, I have mentioned that key.json. So in the key.json, what I have is I have defined this JSON wherein I have two attributes, an artist and a song. I have defined its type as string, and then there it has some kind of value. So basically, what AWS DynamoDB get item, this
first command will do is it is going to look for a table called as music collection, and in that music collection it will look for the column artist, and that value of that artist is no one and it will look for another attribute or the primary key. In this case, both of these is primary and sort key, partition key and sort key for song title, which is named as Scared of My Shadow. So it will look inside the table music collection, and if it has that particular item, it will get back to you. Now let's say you want to insert a value. So in the item.json, we'll look at the definition of item.json. So what I'm trying to do is I'm trying to insert a value for artist, no one can then song title, call me today, and I want to add a new attribute called as album title, somewhat famous. So with this particular item action, you are actually creating a new item. So similar thing happens for update and delete, but for update there is this particular peculiar condition. So here you see I say DynamoDB update item, then title name musical collection, and in the key.json I'm again mentioning what artist and song title are, and then I want to update an expression, and I have something here called as hash y is equal to colon y and hash at is equal to colon t. Now for this hash y and hash at, these are called as expression attribute names. So in your SQL, when you say set name is equal to Anurag, so in that the hash y represents the name and Anurag represents colon y. So this value of hash y is actually present in expression attribute names.json. So expression now I'm going to the next screen. So expression attributes.json says that hash y is equal to year and hash at is album title. So it will look for you could say it will set year as 2015, as you see in the expression attributes value towards the right, and it will update album title as louder than ever. So this is how you are going to do you could say insert updates. So these are CLI actions for the item-based API actions. Now similar things exist for query and scan as well. So what are query and scan? Let's take a quick look at it. So we just saw item-based APIs. Now the one caveat of item-based APIs is you always have to provide the partition key and sort key. So sort key if present, and if not, partition key is only enough. But so as if you look at this particular diagram again, I'm going to go back a bit. So here you see the partition key and a sort key as a combination is going to identify only a single item. So using this definition, all you're doing is manipulating only a single item. Now you can batch together these operations inside a batch job and do sequential updates, but again you are only acting on one item at a time. Now now you might say, okay, I am interested in getting the whole value or the whole data for one particular order. Then there is something called as a query API. So for the query API, it actually works on item collections. So item collections, if you remember, so I'll go back again for the you could say visualization. So on the left, you see that the partition key for this entire table is order hash 001. So basically all these 4 items belong to a single partition key, which is order 001. So this is called as an item collection. So when what query means is you can operate on top of item collections. So you must, so as you might have guessed, you must only provide a partition key. So that is enough to get you that particular item collection, and you can optionally provide sort key and other attributes if you want to do any further filtering. But as you might have seen an you could say pattern here, all your major filtering is happening on the basis of partition key and sort key. So when you get an item collection, inside the collection you can do you could say filtering on top of some attributes, but you cannot say that I want to filter by, let's say, manufacturer in the our example, and do it on a full table. So for that it is possible, but that is something which is not recommended. It is called as a table scan. So as a scan, you as the name suggests, it is a full table scan. It's a very costly affair because it is going to consume a lot of read capacity units for you. So you have to use it very carefully, and only should be used in the cases of, for example, you want to, you know what you're doing and you want to do something like ETL transaction or something like that. Okay, so now we saw what DynamoDB is, what it does, how to access. Now let's look at the how to do data modeling inside this.
So why I say it is different, it is because, like I mentioned previously, there are no joins, there is only something called as a single API, single table design. So it makes the modeling totally different. So these are the high level steps that you need to take when you are modeling data with DynamoDB. So first you need to create a traditional ER diagram. So there is no, you need to identify all the entities and then define all the relationships inside your entity and create an ER diagram. Then you need to sit with your product manager, project manager, or business analyst, or whoever the stakeholders are, and carefully uh, write down all the operations that you are going to do on top of each entity. So this is a very crucial step to identify the access pattern. And then you have to implement these access patterns using primary keys and secondary indexes. So let's take a quick example. It's a very small example, very crude example, but it should give you a gist of how exactly the modeling happens in DynamoDB. So the step one is create an ERD. So I have created this three table for a simple mobile application where I'm trying to store the number of books, the details of the books that I have read. So this is these particular three tables. So user, books to read, and book read. And these are the different attributes, and all, as you can see, all of these definitions are one to many kind of relationships. Now second thing is you need to define access patterns. So these are the access patterns that I have defined for this particular mobile application. So this mobile application was for maintaining a record of books that you have read. So these are the basic requirements. You can create an account using email address. You can add a book you want to read in to-do list. Once you have read, you can scale the book, how good it is on the scale of 1 to 5. You can add summary when you completed that, then optionally load a picture of the book. Then if you want to search your to read list or already read list, you can do with the attributes of title, author, and genre. Then a user also can list their entire to read and already read books. So this is the base requirement for one persona. The second persona here, let's say, is author. So let's say we want to give access to the author, and the author can see that how many people have their books by title in their list, both read or to read list. So when I went through this entire, you could say, process, so there are these three attributes, entities. Now when I see when there is this relationship between of book to read and book read, you see that these are nothing but these are extra attributes that were generally not accommodated in the first table. So that is something that you cannot do in relational databases, but this is something that you can do in DynamoDB. So here I have defined that, okay, there will be only two entities in my DynamoDB. One will be user and the other will be books. And for the user, my partition key is username and sort key is email. For books, my primary key is username and title. Now let's see how this particular access pattern helps us, you could say, cover our requirements. So now this is the table that I have defined. So I have defined, in both the cases, you see that the partition key is username. So on the left, you see that the partition key now is user hash Anurag Kae. And on the right, we defined two different sort keys. One was email and the second was title. So for the first item entry, you see that the sort key is email hash something @gmail.com or anuragkai @gmail.com, whatever the case. And the second sort key that you are seeing, the second and third items that you are seeing, is actually these are the titles of the books that I have read. So first book is Alchemist and second book is Deep Work. So as you can see, for the same partition key, I have different types of attributes for each of these items. For the first item, I have only three attributes: data registry, username, and password. Then second, I have this book read with a status to read. So I want to read this book Alchemist, which is written by Paulo Coelho, its genre, and then finish date by which I plan to finish it. And then the third entry is for the book Deep Work, which I've already completed, you could say, reading. Then I have this extra attributes that you see. I have rated it 5. I have a summary, and I have then image of this particular table of this particular book. So here you see I am satisfying the requirements that were there for point 1, 2, 3, 4, and 6. So just point 5 is not here. So let's go through it again. So I can create a user account using email address. I can do that. The book user can add a book that they want to read in a to-do list. So to read list, I was able to do that. The third is user can rate. So we rated the books on the scale of 1 to 5. The user, we were able to add summary. We were able to add read date, and optionally we were able to load pictures as well. The sixth case was I can list their entire to read or already read books. So to achieve that, all I'm going to do is I'm going to use a query, and in query I'm going to mention that okay, query AWS DynamoDB books, name of the tables. Let's say the books is the name of the table, books where pk is equal to user hash Anurag Kayat. So with this I'm able to list all the books, all the you could say all the attributes or all the books that I'm going to read. Now the requirement 5 says that I need to search the books by using title, author, and genre. So to achieve that, we will look at the how to implement how to get that in terms of using the other features. So for requirement 5, we are going to use an LSI. So LSI was this local secondary index. So what I have done is I have swapped my sort key with author name. So in the right, actually, we had this author column, and then on the left, we had this sort key of book. Now I have swapped my sort key for author, which is coming in place of the sort key, and book is pushed into the other table. So basically now with this particular, you could say implementation of LSI, I was able to satisfy my condition 5. Now for condition number 7, so the condition number 7 says that the author should be able to see how many books have been read by the people, and he wants to see the details. So for condition number 7, I have implemented a GSI which has the partition key as the name of the book or title of the book, and then the sort key is acted as the username. So with this particular, you could say setup, we were able to satisfy the requirement number 7. So now again there is this one small catch. So in the point 5, it said that we need to also filter the books by the user by its genre. So it is pretty straightforward, and if you have understood the query API, if you look at the query API, you will be able to solve this problem. So this is something that I'm going to give as a take home solution, and I hope you will take some time and try to find the solution for it. You can reach out to me on social media if you need the answer or if you want to get your answer checked. Okay, so this so in 45 minutes it's very difficult to, you could say, deep dive into all the readings, all the sections, or all the attributes, or all the different functionalities of DynamoDB. So these are some of the further readings that you can take. Some advanced topics. So DynamoDB streams is one of the topics that you should really look after. And if you want to look for more design patterns, more access patterns, more design patterns, here in the example, we only took a look at one-to-many example, but there could be a use case wherein you need to implement many-to-many or many-to-one. How exactly you are going to model that kind of readings? You can find something in this advanced design pattern talks by Rick Houlihan. He has done this talk in multiple times, but his talk, particularly from reInvent, is very good. Then also, if you want to understand how DynamoDB operates under the hood, you should definitely look at this particular session called as DynamoDB Under the Hood in reInvent. Also, these are the few people that you should definitely consider following on Twitter if you want to know more about DynamoDB. So Alex DeBrie has a very good book called as DynamoDB book, and it's a great resource. Also, Rick Houlihan is actually the product manager of DynamoDB. So he also tweets often on DynamoDB. And then Kirk is also a great guy who works at AWS and who is AWS NoSQL evangelist, and they tweet frequently. Also, if you want, if you have any questions, you can connect with me on Twitter and on LinkedIn. These are my handles. So looking forward to getting in touch with you. Okay, that's it from me. Thank you very much. And if we have any questions, then I think we can, and if we have the time, we can take them. Okay, over to you, Suyok.